let's look at these type of problems using the Pythagorean theorem and a quadratic equation to find the side lengths of a right triangle. Okay, so let's go back and recall what these pieces are. Pythagorean theorem, that's a theorem used in right triangles, and it says that if you take the sum of the squares of the legs, it equals the square of the hypotenuse. And you guys probably remember it as a squared plus b squared equals c squared. Okay, what the definition says is leg squared plus leg squared equals hypotenuse squared. Okay, so let's look at a right triangle. If I'm looking at a right triangle, the legs of a right triangle form a right angle. So you need to look for that right angle, and then you know that those two are the legs. Okay, then the side across from the right angle is called the hypotenuse. So that's kind of a little reminder of that. And that theorem right here says if we sum the legs squared, we get the hypotenuse squared. So let's look at our problem. So we know we're going to have to use the Pythagorean theorem. It's talking about a right triangle. We need to think about a couple things, and it's how to set up a word problem. So let's look at this one. How do we set this problem up? I'm going to start by drawing a picture. I'm a picture person, so get my picture. It doesn't have to be to scale, doesn't have to be look right, you know, whatever. The longer leg of a right triangle is 3 feet longer than the shorter leg. So to get the long leg, I have to have the short leg first. Okay, does everybody agree on that? Hopefully. To get the long leg, I need to know the short leg, because then I know that the long leg's 3 feet longer than, so that would be the short plus 3. So I have to know the short leg first. Okay, then the hypotenuse is 6 feet longer than the short leg. So to the hypotenuse, I have to also know the short leg, because the hypotenuse is 6 feet longer, so it would be the short leg plus 6, and that's going to be the hypotenuse. So then it says find the side lengths of the triangle. So let's go ahead and put the information that we know in the problem. So we know that we have to base everything off the short leg, because we need the short leg to find the other two. So that's going to be our x. So looking at my picture, we would call this one the short leg because it looks shorter than that one. Okay, it doesn't matter though. And then the longer leg, which would be this, remember the legs form the right angle. Okay, the longer leg is 3 feet longer. That means it's, you know, the short plus 3 feet longer. So this side would be x plus 3. And then the hypotenuse, which is across from the right angle, is 6 feet longer than the short leg. Well, we know the short leg is x, right? So it would be short plus 6, so that means it would be x plus 6. So now here is a picture. We have our legs identified, we have our hypotenuse identified, and now we can put it in our formula. And remember, our formula says leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. So I'll let this be my a, this is my b, and of course that has to be my c because the hypotenuse is always the c. You can interchange those. So a squared, that would be x squared, plus b squared, that would be x plus 3 squared, equals c squared, that would be x plus 6 squared. So here's my equation. And now we just have to simplify it and solve it. X squared is just x squared, and x plus 3 squared is x squared plus 6x plus 9, and x plus 6 squared is x squared plus 12x plus 36. Now if you can't do those in your head, you can come off to the side, and I always say when in doubt, write it out, and then you can FOIL that. So first times first, your outsides, your insides, last times last, add those together. Okay, that's where I got that. And then over here, x plus 6 times x plus 6. So first times first, your outsides, your insides, last times last, like terms. And so that's where I got that one from. Okay, so now we just have to clean it up, make it pretty, put it in standard form, and cross our fingers and hope that it factors, because that would make our life so much easier. So we know that x squared plus x squared is 2x squared. And we know we have to get a 0 right here. So we're going to have to subtract x squared, subtract 12x, and subtract 36 to make it 0. So subtract x squared, subtract 12x, and subtract 36 to make it 0. So that gives me the trinomial x squared minus 6x, and then 36 minus 9, is that 27? So minus 27 is equal to 0. Okay, so now we've got a trinomial. We've got a couple of ways that we can solve the trinomial. We know that the degree is 2, so that tells me that I should get 2 x's or 2 answers, because the degree of this trinomial is 2. If it factors, oh my gosh, my life is so much easier. But if you don't like factoring and you want to put it in the quadratic equation, you can. Whatever. You can complete the square. I mean, it doesn't matter. You can do it however you want to. I always go for factoring first. So how do I factor this one? In one of my earlier videos, I think I showed you guys my box method. And that's the way I like to do it. You can do any of them using the box method. So right here is a 1, and 1 times negative 27 is negative 27. And so now I have to come up with things that multiply together to make negative 27. And so that would be a negative 1 and a positive 27, a positive 1 and a negative 27. Remember, ultimately, we're trying to combine them and get a negative 6. So that would be a negative 3 and a positive 9, or a positive 3 and a negative 9. So which of these is going to give me that negative 6 in the middle? And it will be this positive 3 and negative 9. So I can put them in my box. Okay, remember, I write the leading term here. I take the middle term and I break it up. This is plus 3x minus 9x, and those go on the diagonal. It doesn't matter where. So plus 3x minus 9x, and then my constant has to go diagonal to my leading term. So I have to have my first term here and my last term there. Okay, so now we just look for what they have in common. Remember, column, column, row, row. So these columns have in common an x, and these columns have in common a positive 3. Remember, you take the sign of the first box. These columns have these rows have in common an x, and these have in common of 9, but we take the sign of the first box. So that means that my factors are x plus 3 times x minus 9, and that's equal to 0. And then we use that 0 product property. So x plus 3 equals 0, or x minus 9 equals 0. Subtract your 3 on that one, add your 9. So I'm going to get x is equal to negative 3 for this one, or x is equal to positive 9. So my legs, my x can either be negative 3 or my x can be positive 9. So that's saying that this leg right here, this x, because this is plain x, it can either be negative 3 or it can be positive 9. Well, I don't know a triangle that can have a side of negative 3. So this is a solution to this equation, but it is not an answer to the problem that we're trying to answer. So the shortest leg right here has to be 9. The longer leg would be 9 plus 3, which is 12. And the hypotenuse would be 9 plus 6, which is 15. So my lengths are 9 feet, 12 feet, and 15 feet.